What do this cotton t-shirt, the plastic that this water bottle is made of, and my hair and my fingernails all have in common? The answer is that they are all made of polymers. Next question is, what is a polymer? So a polymer is a large molecule made up of several smaller subunits. So how do we make a polymer? We do it by reacting smaller molecules called monomers together, and they bond and form a polymer. And this is called a polymerization reaction. So let's watch a polymerization reaction. Polymers have different properties. Some polymers are very hard and rigid, like the polyurethane hats that you just saw. And some polymers are more flexible and slimy, like this silly putty that I am making out of polyvinyl alcohol and borax. So density is an important property of different polymers, and I have several polymers here, as well as several different types of liquids. And what I want to do is compare the densities of these polymers and learn more about their densities by testing whether or not they float or sink in these different liquids. First, we're going to test polyurethane, which is the same polymer you saw in the demo the University of Utah did. It's used in foams, synthetic fibers, coatings, and various other things. First, we're going to test it in isopropyl alcohol, and you can see that it floats in isopropyl alcohol. Now we'll test it in water. It also floats in water. Next, we'll test oil, and it floats in oil. This is a 10% sodium chloride solution. It floats in that solution. And this last one is a saturated sodium chloride solution. So polyurethane is less dense than all of these solutions. As a good scientist, I'm recording my data. In the column on the left, you can see the different polymers I'm testing. In the top row, you can see the different liquids I'm testing them in. I record an F if the polymer floats, and an S if the polymer sinks. Next, I'll test PVC, or polyvinyl chloride. Polyvinyl chloride is used in pipes, bottles, and bank cards, among other things. We'll do isopropyl alcohol. It's hard to see, but it sinks. It sinks in water. It sinks in oil. In 10% NaCl, it sinks. And in saturated NaCl, it also sinks. The next polymer is polystyrene, or PS. It is used in packaging, CD and DVD cases, and other containers. It's really common in packing peanuts. In isopropyl alcohol, it sinks. In water, it sinks. In oil, it also sinks. In 10% NaCl, it floats. And in saturated NaCl, it also floats. Polypropylene, or PP, is the second most widely produced plastic polymer in the world. It's used in textiles, plastic parts, packaging, and various other applications. In isopropyl alcohol, it sinks. In water, it floats. In oil, it sinks slowly. In salt solution, it floats. And in saturated salt solution, it also floats. The next polymer is polyethylene terephthalate. It is used in fibers in clothing, in containers, and of course, in many other applications. In isopropyl alcohol, it sinks. In water, it sinks. In oil, it sinks. 10% NaCl, it sinks. And saturated NaCl, it also sinks. The last polymer I'm testing is high-density polyethylene. It's used in piping as well as plastic containers. And we'll test it first in isopropyl alcohol, and it sinks. But in water, it's floating. In oil, it's kind of between floating and sinking. It's hovering there in the middle. It is floating on 10% NaCl. and it floats on saturated NaCl. I've added a lot of information to my data table. Up at the top, I've added the densities of all of the liquids that I used. And I also, off to the right, I looked up the actual densities of each of the polymers I tested. So we can see if our results match the actual densities of these polymers. Looking at polyurethane, which floated on all of my liquids, its actual density is between 0.04 and 0.8. If it floated on all of the liquids, that means it must be less dense than the lowest density liquid, which is isopropyl alcohol. So it must be less dense than 0.786 grams per centimeter cubed. And my range of densities for polyurethane are almost all, lower than 0.786 grams per centimeter cubed. So that checks out. Let's look at a different polymer. Let's go down to the third row and look at polystyrene. Polystyrene sank in alcohol, water, and oil, but floated in my sodium chloride solutions, which means it should have a density between the density of water, 1 gram per centimeter cubed, and 10% sodium chloride, which is 1.06 grams per centimeter cubed. If I look at my actual values for polystyrene, there are definitely some values between 1 and 1.06, so that looks good. Looking at high density polyethylene at the bottom, it sank in isopropyl alcohol and then kind of hovered in the oil, so it should have a density really close to the density of oil, which it does. So that checks out as well. Now that you know about these polymers, I have one last thing to show you. There are many household items that actually have the polymer they're made of stamped on them. So this Tupperware has a PP underneath the triangle, so we know it's made of polypropylene. Over here, I have a jug of distilled water, and if I take a flashlight and shine it right there, underneath that triangle, you can see that it is made of high-density polyethylene. And then this plastic cup, if I shine the light on it, and then I move it just right, you can see that PS, which means it's made of polystyrene. So you now know enough to go look around your house and find some different items. You can figure out what polymer they're made of. You can test their density. And if you can't figure out what polymer they're made of, you can test their density and maybe estimate what they are based on their density. So I hope you have a fun time with that, and I hope you enjoyed watching this video.